All right, here's a quick podcast about parallel and perpendicular lines. And so when things are parallel, they have the same slope. So they would have the same rate of increase as far as rise over run, rise over run, rise over run. So they will never cross. All right, so if you have parallel lines, they're going to have the same slope. Now, if lines are exactly the same, they're just going to land on top of each other. So that could happen. Or you could have lines just cross at any old point. That happens a lot also. And then sometimes your lines cross in a special way where they're perpendicular. So where it crosses at a right angle. Okay, so all of those scenarios could happen. So let's look at this first one. The easiest thing to do is to solve for y. So I'm going to subtract 2x there, I guess. Okay. And then over here, I'm going to also solve for y. So subtract 4x first. And divide by my negative 2. Alright, so I get that. And I get that. Alright, so if I look at my slopes, this one's a positive 2, that's a negative 2. So they don't have the same slope. For them to be perpendicular, they'd have to be opposite reciprocal. So like one of them would have to be a half and the other one a negative reciprocal. So like a positive half with a negative 2 would do it, or negative half with the positive 2. So they'd have to be flipped, and one would be positive, one negative. So these are going to cross. They're definitely not parallel and they're not perpendicular. So they're going to cross somehow, but just nothing special. All right. This next one, again, I'm going to solve. So I'm going to bring this 7x over and divide by 8. All right, so here I can, again, this just, the slope-intercept form helps me see things a little bit better. I could reduce this part, but really all I care about is the slope. So I'm not really worried. I'm not solving it to get it in a better form. I'm just solving it to look at the slope. All right, this guy, I'm solving for y, so again, I'm going to get rid of that. By 7, 7, 7. Again, my goal here is to look at the slope, so I don't really care about that. All right, so this time I look at the slopes. They're not the same, so they're definitely not parallel, but they are opposite reciprocals. So one is 7/8, the other is the reciprocal of that, 8/7, and one's negative and one's positive. So these guys, if I were to graph them, they would cross at a right angle. They are definitely perpendicular. All right, so they would cross, with some type of right angle. All right. Okay, this last one, let me switch to blue. This one's already solved for y, so that's awesome. So I'm just going to solve this one. And so I get 2y equals 4x plus 6 by 2. Y equals 2x plus 3. All right, so this time when I look, I have the same slope. And so some people might be like, oh, yay, they're parallel. Well, look at the y-intercept. They actually are the exact same line. So this would be like this example where they're coincident. They're actually on top of each other. So they're not parallel, they're not perpendicular. It's actually, they're what we call coincident. They actually line up on top of each other. So they're the same line. All right, so let me create some space down here. Sorry. So if you know the slope of one line, you can create another line that is parallel or perpendicular. So for example, say I give you the equation y equals 2/3 x plus 8, and I want a line that is parallel to that. Well, you can do y, and all you have to do is copy the slope. Now, you don't want the same y-intercept because you want it to be a different line, but those two lines would definitely be parallel. So if I put that, it doesn't matter. So as long as their slopes match, they're going to be parallel. If I ask you to find a perpendicular line to go with that one, then I would have to do the reciprocal and opposite. And again, any y-intercept is going to work. So again, this slope is the key. So that slope is the reciprocal. So instead of 2/3, 3/2, and then it's the opposite. One's negative and one's positive, and we're good to go. If I want to find a line that's not parallel, not perpendicular, and not the same line, but it just goes through it with kind of nothing special, but it'll cross eventually. Basically, I can pick any slope, you know, negative 4x plus 10. This is not the same, so it's not parallel, it's not perpendicular, it's not the opposite reciprocal. And so I know that this line would cross with this line eventually, not at a right angle, but it's going to cross it somehow.